Hello, I'm Chris from GraphCore, and I'm going to introduce a fun project for evaluating, checking, and writing dwarf expressions that was started recently. Just hoping to get some feedback from the community as whether these tools can really extend beyond a hobby project to something that's really useful for more LLVM developers. So the tools are loosely inspired by an existing tool called Dexter that is used to test that debugging expectations are met. I gained some experience generating and writing non-trivial dwarf expressions while working on salvaging for loop strength reduction. And I was mildly impeded checking the output because the complexity of the generated dwarf expressions. And in fact, I didn't even attempt to salvage a subclass of optimized out values because binomial coefficients are required to calculate these values, and I was reluctant to implement this for the dwarf stack machine. It was by no means would it be impossible, but there wasn't much tool support to help. So this resulted in the idea for a suite of tools to help develop and check non-trivial dwarf expressions. I'll describe two of these tools today. They're intended to make it quick and easy to interpret and check dwarf expressions. And in this context, when I say non-trivial, I just mean dwarf expressions that are very long and difficult to evaluate quickly just by manual inspection. And these expressions can be especially hard to read because of the postfix notation. And so Sinister is simply an interpreter that computes the output of a dwarf expression. Well, computes the result of a dwarf expression. As I mentioned, the desire to write these tools emerged from writing modifications to the salvaging in the loop strength reduction pass. Dwarf expressions were generated from SKEVs, or scalar evolution expressions, but it wasn't convenient to check the correctness of the generated expressions. Additionally, I really want to be able to output individual fragment or piece values of dwarf expressions as well. And the goal is simply to increase the convenience of checking dwarf expressions. So this is just an example of the very first lit test that was written for the Sinister interpreter. And you might notice at the moment that it's limited to constant inputs. And also the result type is limited. But the intention is to significantly expand this, enabling the results to be output in a number of different formats using input flags. So LLVM IR contains dwarf expressions within debug value intrinsics. But internally, LLVM uses DI expressions, which are in fact a superset of the dwarf stack machine instructions. These enable a range of conveniences. For example, periodic debug value intrinsics that can refer to multiple values. But as some tools output dwarf and others D expressions, it might be useful to be able to interpret both of these. So an additional tool, DI expression to dwarf or die to dwarf, converts DI expressions to pure or dwarf spec expressions. The interpreter must support output from several tools within the LLVM toolchain, but instead the idea is to support only a single expression format and separate the translation of dwarf instruction supersets to additional tooling. So a chunk of implementation has taken place without any real serious technical hurdles so far. Sinister, the interpreter, is partially complete, but lacks register context, and I'm working on that right now. That's going to be really important to make the interpreter as useful as possible for checking expressions. And die to dwarf also made good progress, but not quite complete yet. I'm just adding the minimal set of features. So in summary, some work to do before minimum value product, but proof of concept has passed. Potentially some significant changes might be needed to main branch code for register contexts, but we'll see, hoping to carry on implementation without modifying the main branch. And I've got some ideas for more fun tools, Currently, there are optimizations for dwarf expressions scattered throughout LLVM. There's one in DI expression and one in LSR, and I think it would be useful to have these all in the same place so that transforms that generate dwarf expressions can concentrate on the correctness of the expression, and the efficiency can be taken care of somewhere else. I've overrun slightly. Thank you very much. Please come and find me if you have any questions.